Hi, welcome to my new unit on average rate of change and instantaneous rate of change. And this first video deals with the average rate of change by definition. Average rate of change. Definition: how much one variable on an average changes when compared to another variable. Some examples would be a car traveling at a rate of 100 kilometers an hour, and this is the distance, which is kilometers, divided by time, which is in hours. So that means it's 100 kilometers in 1 hour, 100 kilometers in another hour, and 100 kilometers in the third hour. So what happens is that it's represented by this line. This one is a linear. Another example: wages earned at a rate of $20 per hour. And again, we got dollars over time. So $20 per hour. So you go up 20, right 1, up 20, right 1, up 20, right 1. So if you work for 1 hour, you get $20. 2 hours, 40. 3 hours, 60. Now let's continue. Which one is higher rate of change? This is the average rate of change. If a container is being filled, I guess a container is being filled with sand or water, doesn't make any difference. A, if you fill it at a rate of 40 liters in 2 hours, so 40 liters in 2 hours, and reduce it, that's 20 liters per hour. And if you have 100 liters, again, liters as in liquid, 100 liters per 4 hours, reduce it, that's 25 liters per hour. So notice you have the liter quantity, capacity being divided by time. So it's two variables, one divided by the other. And the average rate of change can also be defined as a slope. Let's look at this graph. The graph represents the distance a person travels from home in 5 hours. So notice he starts off at 0 hours and ends at 5. So along the way, in each hour, he's walking differently at different speeds. And to complement this, we could have time 1, D1, and we could have time 2, D2, between each interval. So that means that's the average. We want to find the average rate of change. And the average rate of change is the speed. And so we could call the average rate of speed the slope. So the slope is D1 minus D2 over T2 minus T1. Again, it's like the x's and the y's. That's x and that's y. So it's a slope. It's the difference in the distance divided by the difference in the time. So the difference in the distance is how many units or kilometers you traveled over the number of hours it took you to travel it. So let's find the different average rate of change for each time interval. So from 0 to 2, so 0, he's at 0 distance, and at, sorry, I said 0 to 2, 0 to 1, and at 1 hour is 50. So if you subtract, you get 50 minus 0 over 1 minus 0, so that's 50 over 1, and it's 50. Again, it's distance, it's 50 kilometers per hour. Now, what about how fast, what was the average rate of change from 1 to 2? 1 to 2 hours. So at 1, he was 50 kilometers, and at 2, he was 150. So the rate of change is 150 minus 50 divided by 2 minus 1. So that's 100 divided by 1. So that's 100. Oh, make it 100. That's 100 kilometers per hour. And how fast did he travel from between 2 and 3 hours? Between 2, so 2 is at 150. And at 3, he's still at 150. So that's 150 minus 150. And 3 minus 2, so that's 0 divided by 1. So that's 0 kilometers per hour. And that makes sense because notice that the time went from 2 hours to 3 hours, but the distance never changed because it's a horizontal line. And the horizontal line has a slope of 0. So any horizontal line on a graph represents a slope of 0. What about from 3 to 5? So 3, at 3, he's 150 kilometers away from home. And at 5, he's 50 kilometers away from home. So that's 150 minus 50. Oh, my mistake. See that? 50 minus 100. It's 50 minus 150 over 5 minus 3. So that's negative 100 over 2. So that's negative 50 over 1. So it's 50 kilometers per hour. And notice that the negative 50 is the slope, but the slope is negative. So that means from third hour to the 5th hour, he's walking back home. And notice here, from 0 to 1 is positive, so he's going away from home. From 1 hour to 2 hours is positive, so he's going away from home. Just notice it. So what's the average rate of change from 0 to 5? So even though I'm looking at this slope of this line here, so 0 is a 0 and 5 is a 50. So 50 minus 0 over 5 minus 0 is 50 over 5, which is 10. So that's 10 kilometers an hour. So notice from 0 to 5, you have to do the slope. But notice the slope of this line is smaller. So on an average, from 0 to 5, he only walked on an average, from walking 5 hours, walking 50 kilometers, he only walked on an average of 5 or 10 kilometers per hour. And what about 0 to 2? 0 is 0 hours, 0 distance, and when he's at 2 is here, is 150. So that's 150 minus 0 over 2 minus 0. That's 150 over 2. So that's 75 kilometers an hour. So notice, again, from, did I say 0 to 2? Oh, 0 to 2. 0, so that's this, let's look at this line right here, 0 to 2. So notice how steep this is. This is the steepest distance from 0 to 2. So which time interval is this is the steepest one? So again, we're 150 kilometers in 2 hours, so that's 75 kilometers an hour. So notice the average rate of change depending on the interval. So it's the distance divided by the time. Which time interval has the fastest speed or the fastest rate of change? And the answer is the time interval is 0 to 2 is the fastest. 0 to 2 hours, because it was 75 kilometers an hour. And notice the slope. That's the steepest line. Up 150 over 2. Notice how steep the line is. There's no other line here or line segment steeper than this one. So from 0 to 2 is the fastest speed, fastest rate of change. And again, the rate of change is done by the one quantity divided by another quantity. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. The content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.